All right, for one more definition stuff, we're going to talk about what a classic probability is. So, the probability of an event occurring, so the parentheses are like when you have function notation f of x, this is probability of whatever your event is equal to the number of ways you can have a success divided by the total number of different outcomes. So if we think back of rolling 2 dice, and I ask what's the probability of getting a 5, alright, I would look at my chart, and I would count out the number of 5s on it. So here's the chart again. I have 1, 2, 3, 4 different 5s, so there's 4 ways that I can roll a 5, a 1 and a 4, a 4 and a 1, a 2 and a 3, a 3 and a 2, divided by the total number of outcomes. Now for rolling 2 dice, oh look, 6 different for the different bases, so it's a total of 36. So it's 4 divided by 36. Now, you have been conditioned and trained throughout school to reduce this fraction, right? 4 goes into 4 once, 4 goes into 36 9 times, all right? And we could use a calculator to also get 1/9, or 0.1111, or we could round it to 0.11, depending on where we needed it to be. All of these are valid. All of these representations have the same meaning. You got to watch out in the back of the book on the paper homework for this one in particular, where they round things and it's different than what the fraction would be. It's a real pain in the rear end. Personally, I like 4/36. I prefer not rounding this at all, not reducing it at all. When you reduce it to 1/9, you lose information. The definition is the number of successes divided by the number of outcomes. On 2 dice, do you have 9 different outcomes? No, you had 36 different outcomes. Was there only one way to get a 5? No, there was 4 different ways to get a 5. This contains more useful information to somebody using statistics and doing work with this than the reduced fraction. But with the work that we do, with the answers in the back of the book, they do reduction a lot of the times. Admittedly, in the real world, most of the time, we're using reduced decimals, rounded decimals, all right? And your rounding rules will vary from industry to industry for how accurate you need to be. Just be aware that if you have something as simple as 1/8, which is equal to 0.125, that the back of the book might have this as 0.13. And you might be wondering how they got 1/3 from 1/8. Well, that's because they took the decimal and rounded it.